Hello friends, and welcome to this video. In the previous video, we learned about uniform and non-uniform motion. So in this case, and so in today's video, we'll learn about this topic called the rate of motion. Okay. So what is the rate of motion? Rate of motion that we are going to discuss, and we'll also learn some concepts during the course of this video. So in order to calculate the rate of motion of an object, we need to know, okay, to know the rate of motion of an object, we need to know some information, okay. So what are those information that we require to calculate the rate of motion of an object? Those informations are how much distance the object has moved, okay, and how much time it has taken to move the same distance. Okay, so two concepts: how much distance and time. Okay, distance and how much time. Suppose an object has moved maybe 50 meters and time it has taken is maybe 5 seconds. So with these two informations, can we calculate the rate of motion of the object? That we are going to check here. Okay. So the rate of motion in physics is termed by this quantity. This term is specified by this particular term, which is called speed. Okay, and it's measured in units of in several units. It is measured maybe meter per second, centimeter per second, kilometer per hour, etc. Okay. So once again, what are the information? So how much distance it has gone? Distance is measured by meter, centimeter, kilometer, etc. And how much time it has taken? Time is measured by second, hour, minute, etc. Okay. So these two informations are required to specify the rate of motion, and the rate of motion is equal to speed. Okay, rate of motion is equal to speed. Okay, that is what we have learned so far. So to specify the speed of an object, we require only the magnitude. Okay, magnitude, it means a number. What is magnitude? Magnitude is a number. Okay, so how many students are in a given class? Maybe your answer is maybe 50. So 50 is the magnitude. Okay. In most cases, the objects have non-uniform motion. Okay, so in the previous video, whose link I will give somewhere in this video. So most of the objects that we see around us are non-uniform. They have non-uniform motion. Okay, that is what we discussed in the previous video. So when we have to calculate the speed of an object, what is again the speed of an object? That is nothing but the rate of motion. In that case, what informations we'll need? We'll need is total distance traveled. Okay, how much distance has been traveled by an object? Okay, how much distance has been traveled by the object, and that distance has been covered in how much time? Total time. Okay, so mathematically average speed. Okay, why average speed? Why are we using the term average speed here? That is because most of the objects have got non-uniform motion. Okay, the rate of motion in such objects is given by average speed. So in case of non-uniform motion, the motion is measured by average speed. So again, how we can measure average speed? Average speed can be measured by two informations. If we have two informations in hand, how much distance the object has traveled and how much time it took to cover that distance. Okay, I hope you have understood. Suppose for this example, in this example, where we considered initially that the object covered a distance of 50 meters. In how much time? In suppose 5 seconds. So what will be the average speed in this case? The average speed will be 50 divided by 5. Write down the units, meter per second, which will be 50 divided by 5 is 10 meters per second. So in this case, the object will have a speed of 10 meters per second. Okay. So in general, how do we measure average speed? If an object travels a distance of s, okay, in time t, okay, suppose you have any object which has covered a distance of s at a given time of t, then its average speed is given by this expression. Okay, average speed is given by s divided by t, distance divided by time. For example, here one example is given. We have already shown one example just now. So one object travels 100 kilometers in 2 hours. Okay. So what will be its average speed? Its average speed calculation will be very easy. So just divide 100 by 2 kilometer per hour. So this would give us 50 kilometer per hour. That would be the average speed of the object. Okay. Okay, so now speed with direction. So it's going to be, so far what we have learned about speed. Okay. So in speed, when we specifically talk about speed, so it's direction thing we do not, so direction is not considered. But what if speed is used in conjunction with, sorry, this is speed plus direction. So if we have both speed and direction in the motion of an object, then what would we get? Okay, what we get is this term again. This term you must have heard many times. So far, that term is called velocity. Okay, you might have heard people talking informally about speed, velocity, but remember, speed means it does not have a fixed direction. But when we are talking about velocity, it has got a definite direction. Okay. So speed with direction. The rate of motion of an object can be specified better if we can specify the direction of motion. Okay. The rate of motion can be specified better with the direction of motion. The magnitude of speed along with direction gives us velocity. Okay. So speed plus direction, that gives us velocity. The magnitude of speed along with direction gives us velocity. In other words, the velocity of an object is its speed in a given direction. Okay. So velocity definition, to be precisely, if we have to give the velocity definition precisely, what is velocity again? Velocity is equal to speed plus direction. Velocity is equal to speed plus direction. Okay. And when we specifically talk about speed, it does not have this direction term. But when we talk about velocity specifically, it will have a direction component attached to it. Okay. When an object is moving along a straight line, okay, for example, when an object is moving along a straight line at a variable speed, we can express the magnitude of the rate of motion as average velocity. Okay. So speed means, velocity means the object is having a direction. Okay. Suppose this is a straight line motion. Okay. And an object is there. Suppose a ball is there. It is moving along a straight line. So it will have an average velocity. Okay. So the rate of motion of this ball in this particular case will be explained by average velocity. Why we can express average velocity, the rate of motion? Because the ball is always moving in a given direction. Given direction is towards the right. Okay, it will not be moving down, up, left. No, it will be only moving along one given direction or particular direction. And in such a case, the object will be having an average velocity. Okay, so once again, what is velocity? Velocity is nothing but speed with a fixed or given direction. I hope you have understood the concept of velocity. So the rate of motion, now one more concept. So if the velocity is changing at a uniform rate, then the magnitude of average velocity is the average of the initial and final velocities. Okay. Suppose we have an object and that is that's velocity is changing at a uniform rate. Okay. Suppose it starts from 0. At some point, it has a velocity of u. U is the initial velocity. At another point, it has got a at the final point. It has at the finally the object has achieved a velocity of v. Okay, in that case, what would be the expression for average velocity? In that case, the average velocity is simply given by the summations of initial and final velocity divided by 2. Okay, I hope this you have understood this, how you can calculate average velocity. Average. So once again, average velocity is simply the average of initial and final velocities. Okay. So now some more points about the rate of motion of an object. The change of velocity of an object is 0 during uniform motion. It always maintains a constant velocity. Okay, so very interesting thing to note here. So what is the, so what do you understand by uniform motion? Uniform motion means, already we have discussed in another video. Uniform motion means the object covers equal distances at equal intervals of time. Okay, that means its rate of motion would be constant. For uniform motion, what would be the rate of motion? Rate of motion for uniform motion, rate of motion for uniform motion would be constant. Okay, the rate of motion throughout the entire motion of the object would be constant. Therefore, the change in velocity would be simply equal to 0. Okay, because the object always maintains constant velocity. Okay. So I hope you have understood this, because the velocity, if the velocity does not change, so will there be any change in velocity? I mean, if the motion is uniform, that means its velocity is constant. Okay, once again, uniform motion is, its velocity is always constant. That is what you should remember. Uniform motion means velocity is constant, and therefore the change in velocity of the object would be equal to 0. But what if the case is like a non-uniform motion? In a non-uniform motion, the velocity of the body is not constant. Okay, because in non-uniform motion, the definition is the object covers the object covers unequal distances at equal intervals of time. In that case, the velocity would not be similar. Okay, the velocity of the body is not constant. In that case, the velocity of the object changes with time. Okay, therefore the rate of change of velocity is not 0. In case of a non-uniform motion, the rate of change of velocity is not 0, because initially the velocity may be, suppose, 3 meters per second. Then maybe velocity is 5 meters per second. Then maybe velocity is 1 meter per second. Just remember the example which was given in the previous video, a vehicle moving in a traffic. So in that case, the velocity of the vehicle would keep on increasing and decreasing due to the traffic. And in such a case, the object will have non-uniform motion. That means its velocity would be different at different time intervals, or the object would simply cover unequal distances at equal time intervals. Okay. Now, there is a concept called acceleration, which comes from the rate of motion concept. So what is an acceleration? The physical quantity used to express the rate of change of velocity is called acceleration. Okay, very interesting thing. So rate of change of velocity. So what is velocity again? Velocity is the rate of change of motion in a given direction. But what if velocity itself is changing? Velocity itself is changing. In that case, we will have to use another quantity in physics, which is something called acceleration. Okay, acceleration means a gradual increase in velocity of the object with time. Of course, the velocity of the object can increase or decrease also. If it increases, it is called generally acceleration. And if the velocity keeps on decreasing with time, it is called deceleration. Okay. Okay, so here an example is given. Consider the following table. Time, initially the object has a velocity of 0 meter per second. Then in 5 seconds, it has got a velocity of 10 meters per second. Then in the next 5 seconds, it has got velocity of 12 meter per second, next 5 seconds, 15 meter per second, next 5 seconds, 18 meter per second. So you see the time interval here is same, 5 seconds. Okay, in each case, the time interval is 5 seconds and 5 seconds. But the velocity change, have you seen it? It is the velocity change is not similar. The velocity change is not uniform. It is always changing. It is 10 meter per second. Here it's like 12 meters per second. Here 15 meter per second. Here it is 18 meter per second. Okay, so velocity is changing with time. In such a case, the object is said to be accelerating. Okay, because you see its velocity is gradually increasing with time. So this object in this case is said to have an accelerated motion, or in simple words, we can say that the object is accelerating. Once again, what is acceleration? Acceleration is the rate of change of velocity. If the change of velocity is not zero for an object, that means the object will be accelerating. Okay, I hope you have understood the concept of acceleration. You can pause this video and look at this table. So you can, and if you do the calculations here, so you can calculate, you can find out that this, in this particular case, the object will have an accelerated motion in this particular case. Okay, so a little bit about acceleration. So acceleration is mathematically defined as change of velocity divided by time. Okay, as we have already shown in the table previously, in this table. So acceleration is change of velocity divided by time. So if the velocity of an object changes from an initial value of u to a final value of v at a given time t, okay, and then acceleration a of the object is given by a equal to v minus u divided by t. Okay. So what is acceleration? Acceleration is simply a change of velocity divided by time. Okay. Suppose the final velocity which the object has achieved is v, and initial velocity which the object had was u. Okay, therefore the acceleration would be v minus u. What is v minus u here again? V minus u is equal to this change in velocity. Okay, as we have shown here, this change in velocity is v minus u divided by t. Okay, t is the time. T is the time in which the velocity of the object has changed from u to v. Okay, so acceleration is equal to v minus u divided by t. So acceleration is positive in the direction of velocity and negative if it is in the opposite direction. Okay. So if the if an object is moving in this direction and its velocity is increasing, acceleration is positive. And if an object is moving again in this direction, but its velocity is decreasing with time, in that case, the acceleration will be negative. Okay. And the SI unit of acceleration is meter per second square. Okay. So how meter per second square? Let me show you quickly. So what is acceleration again? Acceleration is change of velocity divided by time. So what is the unit of velocity? That is meter per second. What is the unit of time? That is second. So meter per second multiplied by 1/second, which will give us meter per second square. Okay. So this is the unit of acceleration. Very important unit that you have to remember because it will be used in future classes. Okay, so here the rate of motion, okay, for an object traveling in a straight line, if the velocity increases or decreases by equal amounts at equal time intervals, the acceleration is uniform. Okay, so acceleration can also be uniform for a body if the velocity of the object increases or decreases at equal amount of time. Okay? So just recall uniform velocity example. Okay, if an object travels equal distances at equal intervals of time, the velocity of the object is uniform. Similarly, acceleration can also be uniform if the velocity change is uniform at equal interval of time. Okay. If the velocity change is non-uniform, the acceleration is said to be, and the acceleration would be non-uniform. Okay. If the velocity change of the object is non-uniform, or in other words, look at this example. This example here, the acceleration would be non-uniform because the velocity of the object is changing by different values at different intervals of time. In that case, the body or the object will be having a non-uniform acceleration. So we will understand some velocity and acceleration phenomenon by graphical method in the next class. So for now, I think we will stop here for now and watch the video again. And if you have any questions, let me know in the comment section. And thank you very much for watching. Do subscribe to this channel and share it with your friends. Thank you very much again. See you in the next video.